Related rates. Related rates problems allowing us to compute a rate of change of one quantity in terms of the other quantity. That's the procedure. The procedure looks exactly the same like any procedure for the word problems, the mathematical word problems. The only thing is that we have to remember for the related rates that each quantity involved is a function of time. That means having a diagram, labeling, having a labels, putting some quantities, X, Y, Z, any quantities, we have to remember by differentiating that they are the function of time. They depend on time. Always involve a chain rule. Okay, example number 1. A paper cup has a shape of a cone with a height 10 centimeters and the radius 3 at the top. If water is poured into the cup at the rate 2 cubic centimeters per second, how fast is the water level rising when the water is 5 centimeters deep? That means what is given? Given information is 2 cubic centimeters per second, which is the volume we can recognize based on the units cube. It's the rate of change of the volume of a blue cone of the water inside. That means rate of change of volume with respect to time, since this is function of time, is 2 centimeters cube per second. Now, what we're looking for, the required information is how fast is the height changing. The rate of change of height with respect to time, we're looking for this. And since this is constantly changing, we have to identify one moment at the time. That means we're looking for the rate of change of height at the moment that the height is 5 centimeters. But please note, I can even cross this out, height is not really 5. Height is changing, constantly changing, since the water is constantly going in. I will uncover this, and of course I will use as soon as I will get a formula for dH dt. Then I'm looking for dH dt at the moment that height is 5. For now, I can't use it 5. I have to use h as a function of time. That means we have a given information, we have a required information, and we're looking for the relationship, and the relationship is given. It's simply a formula for the volume of the cone. 1/3 pi r squared h. This relation is good. However, we do have v, which we have some information. We have h. The only problem that we see is the radius. We have no information how radius is changing. That means one of the way is to rewrite radius in terms of h, and then have the relation only between v and h, and then differentiate in order to have the relation between dv and dh. How can we relate r in terms of h? We nicely see as similar triangles. Similar triangles. I see the big cone with the dimension 3, radius, and 10 height. And I also see the small cone, the water one, with radius r and height h. R and h. Okay. And please note, this is the moment that I'm not using for h5, because h is not 5, h is constantly changing. Okay. Let's get the relation. The ratio for the similar triangles, 3/10, is the same like r/h. Let's relate r in terms of h. R will be 3h/100. And this r will go here. Let's substitute and simplify. Pi/3, radius squared which is 3h over 100 over 10. I believe I squared already. One more time, 3h over 10, of course 10. Probably you can guess why I said 100. Okay, 10, still 10. Now, let's see, pi over 3. Now, let's square. 3 squared is 9, 8 squared is 8 squared, and 10 squared is 100. 9 over 3 is 3 pi and 100, and 8 squared times h is h cubed. That means now we do have really nice relation just between v and h. I think we're ready to differentiate because we have to find a relation between rates of change. Okay. Derivative of v is dv dt, since it's the function of time. Copy constant, 3 pi over 100. Derivative of h cubed is 3h squared times dh dt, since h is a function of time. Perfect. Now I can substitute all of the given information. dv dt is 3 pi. Let me write everything here. dv dt is 3 pi over 100. 3. And now h, I'm looking for dh dt at the moment that h is 5. 5 squared. Now I can uncover and I'm substituting instead of h 5. And dh dt. Let's simplify. 3 times 3 is 9 pi, 100. 5 squared is 25, dh dt. 25, I can simplify. 100 divided by 25 is 4. Okay, 4 times 2 is 8, 9 pi dh dt. And solving for dh dt, the rate of change of height, I'm gonna have 8 over 9 pi. And my units are distance, centimeters per second. This is the final answer. That means this is nice example, since we do have a main relation and we also have additional relation in order to get a proper connection between v and h. I do have example number 2, which is identical concept, identical question, just different values. I would like you to practice and try to get the correct answer. And that's the correct answer. 29 pi meters per minute, just different units. Example number 3, the multiple choice. Another volume, but different shape. The volume of a spherical balloon is increasing at the rate 25 cubic centimeters per minute. How fast is the radius of the ball increasing when the radius is 2 centimeters? That means the given information, let me use the shortcut, the given information, again, based on the unit, I'm guessing, is a volume. The size of the balloon, dv dt, is changing with the rate 25 centimeters cubed per minute. The required information is how fast is the radius, how the radius is changing, dr dt, at the moment then the radius is 2. But of course, the radius is not really 2. Okay. As soon as I get the relation between the rates, I can substitute 2. Okay, that means my relation, again, it's really nice, is provided, is the formula for the volume of the sphere. Volume is 4/3 pi r cubed. And this question is even easier than the previous one because we do have right away the relation between v and r, between the given and the required information. Okay? Let's differentiate. dv dt, 4 pi 3, that's constant. Derivative of r cubed is 3r squared dr dt, since radius is the function of time. Let's simplify. And now let's substitute all of the given information. dv dt is 25, 4 pi, now radius is 2, dr dt. Now I can uncover and I can definitely substitute. Okay, that means solving this equation for dr dt, we will have 25 over 4 times 4, 16 pi. And the units are distance, centimeters per time minute. Okay, and I believe one of the answer is like that. That's the option. Okay, three nice and quick question. Example number 4. A rocket travels vertically at the speed 20 kilometers per minute. The rocket is tracked through the telescope by an observer located 30 kilometers west from the launching pad. Find the rate at which the angle between the telescope and the ground is increasing when the rocket has traveled 40 kilometers. Okay, that means what we have. We do have a rocket. Let's say that's the rocket is traveling up, of course. And that's the launching pad, and that's the telescope, which is 30 kilometers apart. And the telescope, of course, is looking at the rocket this way. That means this angle is the angle between the ground and the telescope, which I can draw just one nice triangle. That means this distance is the rocket speed. This distance x is changing with actually the rate 20 kilometers per minute. That's that because that's my rocket. dx dt is changing with 20 kilometers per minute speed. That's given. That's my angle. That's 30, which is not changing. You can see I can label 30 and it's constant. This distance between the launching pad and the observer is 30. And required information, we're looking, find at what rate is the angle changing, d theta dt. At that x is 40 kilometers, okay, up. That means having a right triangle and angle involved, always please remember trigonometric ratio are the good ratio, good relations. And I can see what I can see. I can see angle, and then I can see the opposite side involved and adjacent. That means I believe tangent will be a good relation. Tangent theta is x over 3, over 30. I can solve for x just to avoid fraction. Okay, that means now we do have nice relation between x and theta. We can differentiate to get the relation between the rates, related rates. The derivative of x is dx dt because it's the speed, is the rate of change of the distance with respect to time, speed. 30 constant. Derivative of tangent is secant square theta times d theta dt. Follow the chain rule, follow the inner function because theta is the function of time. Okay. And the same thing, I will not use 40, of course, I didn't cross it. I can use at the end. That's me now, I can substitute everything. dx dt is 20, this is 30. Secant theta Okay, that means secant theta squared. I still don't know what is theta, and d theta dt. That means now we do have one extra step to do. My rates are related the way that I don't really see the x. I don't see the distance x. Yes, we can see dx dt, d theta dt, and actually we need the value of theta. That means what I will do, I have to use this because this is the moment of the time that I am looking for the rate of change of the angle. That means let's see at the moment that x is 40, let's see the situation. This is 30, this is 40, and from the Pythagorean identity, we can compute the hypotenuse, 50, 3, 4, 5, 30, 40, 50. And that's my angle. Now, having a right triangle solved, I can easily get any ratio, and I need secant theta. That means secant theta at the moment that x is 40 secant is the reciprocal of cosine. That means secant theta is 50 over 30. Secant theta is 5 over 3. That means I can substitute this to my equation. Am I correct? Let me just double check. Yeah, that's correct. That means I will substitute 5 over 3 to my equation. And we can see we do have additional relation and d theta dt. And let's simplify a little bit. I can squeeze my equation here. 20, actually I can divide by 10. I don't have to carry the zeros. 2 equals to 3 times 5 squared 25, 3 squared 9, and d theta dt. Let's simplify one more thing. 9 divided by 3, it's 3. And now let's cross multiply. 3 times 2 is 6. And what's left? 25 d theta dt. Solving for d theta dt, I will have a quantity 6 over 25, and always is radians. The time was in minute. Radius per minute. Radians per minute. Okay. That's also nice question, since we used trigonometric identity as a relation. That means always a little bit of values of unit circle is important, or the right triangle. Oh, I can actually box the final answer. Okay, and I have one more example. Jim lives 3 miles east from State College. At noon, he leaves his house and begins to walk due east at the constant speed of 2 miles per hour. Annie lives 4 miles north of State College. At noon, she leaves her house and begins to bicycle due north at the constant speed of 8 miles per hour. Calculate the rate at which the distance between the two people is changing when it's 1 p.m. Okay, that's what situation we have. Let's say this is State College. Jim lives 3 miles east. That means I can say this is 3 and that's Jim. And at noon, that's important, at noon, he leaves the house and begins to walk east. That means he is walking, that's his distance. Let's say I will stop at the moment. Now, Annie lives 4 miles. Maybe I can draw a little bit lower because I need 4 up. State College, 3 miles. and Jim starts walking. That's X. Now, she lives 4 miles away and she starts biking north at the rate, and Y will be her distance, which we know how the distance is changing, 8 miles per hour. Calculate the rate at which the distance between two people are changing. That means Z. Okay, let's see. The given information is the rate of change of X with respect to time, which is just the speed of Jim, 2 miles per hour. And also the rate of change of Annie, dy dt. She actually is faster because she's biking 8 miles per hour. Required information is how distance Z is changing with respect to time at 1 p.m. That means what we can do, we can calculate at, let me put this, at 1 p.m. But at 1 p.m., I can calculate the distance X and the distance Y, and possibly distance Z. That means since it's only 1 hour, okay, only 1 hour, this means that Jim, since he's moving 2 miles per hour, the distance X will be 2, okay? 2 miles. And Annie, she moves 8 miles per hour. That means after 1 hour, she just moved 8, which the entire side of the triangle, okay, will be 8 plus 4. Make a little bit straight. Because we definitely have the right triangle. Okay, that's me now. Let's see. We probably need a Z, but let's see what we have. That's me now. I still see the right triangle, like my previous example, but I don't see any angle. Since I don't see any angle involved, I will not use the trigonometric ratio. Having all of the angles involved, like X, all of the sides of the triangle, adjacent, hypotenuse, opposite, or I must say all of the sides, because I shouldn't really name, because that's from the trigonometric. However, having all of the sides involved, I will use Pythagorean identity. That's me. Let's see. This side will be 3 plus x squared, 4 plus y squared equals to z squared. Okay, that's me. That's my relation, Pythagorean identity. But please remember to add 3 and 4. And now let's differentiate. Chain rule, of course. The quantity 3 plus x squared, the derivative will be 2 times the quantity 3 plus h times derivative of 3, 0, times derivative of x, dx, dt. Plus the same thing for this one. Quantity 4 plus y squared, the derivative is 2 times 4 plus y, times derivative of 4, 0, derivative of y, dy, dt, the inner function. Z squared, derivative of quantity z squared will be 2z dz dt. Excellent. Each quantity contains 2. I will divide by 2 just to simplify. And now that's the related rates. That's how they relate to each other. Now I can substitute any other values. Because please note, in my blue box, in my original relation, I didn't put for x2 and for y8. That's not the case. The case is now. That means 3 plus 2, and the rate of change of x is 8, plus 4 plus 8, and the rate of change of y is, or actually the rate of change of y is 8, the rate of change of x is 2. And z, I will also need a quantity z. Okay, let's draw this triangle. The whole side at 1 p.m. 3 plus 2, this is 5, 12 8 plus 8 is 12. That means I can easily compute z, which will be 144 minus plus 25 and square root, which means the square root of 169 is just 13. I believe it's 13. Or maybe I'm wrong. 12, 13, I think is 13. Yeah, no, hang on. Am I? Oh, what is 13 times 13? It's 3. I think it's correct for some reason. I'm just okay. 13 dz dt. Okay, and now solving for dz dt, the rate of change of z, we will divide the entire left-hand side by, and this will be 3 plus 2, 5, 5, 3 plus 2, 5, 5 times 2 is 10, and then that's plus actually 12 times 8. I will save 10 plus 12 times 8 is 80 and 16, 96. Okay, 106 over 13. And the rate of change, of course, is like speed, miles per hour. Okay, I think I did my arithmetic good, except my 13. 169, of course, is 13. Okay, that means that's the correct answer. And hopefully one of them matched to my option, to my answer. Okay, that means the message for you is having a right triangle, and if the angle is not involved, most likely we will use the relation like a Pythagorean theorem. Okay? Please go through all of these problems one more time, and I think you will build your confidence in related rates. Thank you.